Hello, so we're going to be doing number 17, and right off the bat we can tell that we're going to be using a comparison. So the first thing that I know we're going to be using a comparison is because of this plus 5, this dangling plus 5, and if we remove that, then we would get like a bigger value, right? Because we're making the denominator smaller, so the total value will be bigger. But we also notice that it's n squared over n cubed, and n squared over n cubed basically just simplifies down to 1 over n. But how does this work? I mean, we can go through it. So that would be, if I'm just going to remove the 5 first, it's going to be n squared minus 3n over n cubed plus 4n. And here we can see that we can factor out an n from this problem. So it would just be n minus 3 over n squared plus 4. And we can even take this a step further, right? We did it here, so we're just going to do it here again and just remove these ones. And that's going to be, we just continue along here. It's going to be n over n squared, but right, we know n over n squared, that's just 1 over n. So these arrows are kind of confusing. Let me make them the right way, right? So it's getting bigger and bigger. The value's getting bigger and bigger, but 1 over n, right, this is a harmonic series. It's harmonic. And it's divergent, right? Because we know that harmonic series are non-divergent. So, but when we're taking this in terms of the comparison test, if this was our an, let me just erase that. If that was our an, and this is our bn, in order for the series to be, in order for an to be divergent, an has to be bigger than bn, and that's not the case, right? So this fails the comparison test. But just because it fails the comparison test doesn't mean that we can't find whether it's convergent or divergent. Usually when it fails the comparison test, we can just move on to the limit comparison test. And the limit comparison test says that we're going to take the limit as n goes to infinity of an over bn. So in this case, our an is n squared minus 3n over n cubed plus 4n plus 5. So that's our an. Now we're going to put it all over our bn, which is 1 over n. So this can be rewritten as the limit as n approaches infinity of n squared minus 3n over n cubed plus 4n plus 5 times n over 1, because we're multiplying by the reciprocal of 1 over n. So now we can simplify this to the limit as n goes to infinity, and now we're just going to factor this n in, multiply that n in, so it's going to be n cubed minus 3n squared over n cubed plus 4n squared plus 5. And to continue this, we notice that we have n cubed on top and n cubed on bottom. So we know that we can just multiply by 1 over n cubed in order to, get rid of that highest power. So when we do that, it's going to be limit, can't forget the notation, as n goes to infinity. So 1 over n times n cubed is just 1, right? So that's just going to be 1. And then negative 3n squared over n cubed, that's just equal to minus 3 or negative 3 over n. It's going to be all over to the same thing. So n cubed divided by n cubed is 1 plus 4n squared divided by n cubed is 4n. And we're going to just add 5 divided by n cubed. And now we can just do DSP, right? So if we do DSP right here, that's just going to come out to 1 minus 0 over 1 plus 0 plus 0, which is just equal to 1. And the limit comparison test says that this value over here is equal to c, but c has to be greater than 0. And that checks out because 1 is greater than 0. So therefore, it is divergent by limit comparison test to known harmonic harmonic divergence, right? Because we know that this one is divergent. Therefore, this first one, or AN, also has to be divergent.